Welcome to my channel Civil Law Lab. Today we are going to derive an expression for discharge through a Venturimeter. This one is from the subject Fluid Mechanics and Hydraulics. Firstly, we should understand the Venturimeter. Venturimeter is a device that is used to measure flow through a pipe. Suppose this one is pipe, here is a pipe. And if we measure the discharge in this pipe, we should install a Venturimeter. Here is a Venturimeter. And from this Venturimeter, we can calculate the discharge in this pipe. The Venturimeter has three parts. One is converging part, one is the diverging part, and one is throat. The converging part is that part in which the flow will be converged, and from throat it will discharge out towards the diverging part. Similarly, the length of the diverging part is about 3 times more than the length of the converging part. And now, if we want to calculate the discharge, we have to install a glass tube here in 2 sections. One is in the inlet zone or before the inlet zone, which is in the pipe, and one is on the throat part of the Venturimeter. There are 2 glass tubes. The water will rise through the glass tube up to a certain height in these 2 sections. Represent the pressure head of the pipe and throat, and we are considering here as be the difference of pressure head between 1 and 2 sections. Now let's start. Suppose a Venturimeter is fitted in a horizontal pipe. Here one is horizontal pipe. In this pipe, we are fitting this Venturimeter into the pipe where we are going to calculate the discharge. Where fluid is flowing. The fluid may be water or another liquid. Then let D1, this D1 be the diameter of pipe at section 1. Here are 2 sections, 1 and 2. One is in the pipe or before the inlet, that is inlet. This one is inlet. And another one is in the throat. Similarly, P1 be the pressure at section 1. In this one section, P1 be pressure and V1 be the velocity of flow at section 1. And ultimately, A1 be the area of pipe at section 1. We can calculate the area from the diameter by using pi d square by 4. Similarly, for the section 2, we should also consider these variables, and P2, D2 diameter, P2 pressure, B2 velocity, and A2 is area are the corresponding means diameter, pressure, velocity, and area, corresponding values for the section 2. We should use 2 equations here. One is Bernoulli's equation, another one is continuity equation. Bernoulli's equation says that the total head at section 1 and section 2 should be equal. Total head is the sum of pressure at datum head and velocity head. So we can equal the head at 1 and 2. So now, using Bernoulli's equation. This equation says that total head section 1 equal to total head section 2. The total head is the sum of pressure head. Pressure head means P1 by rho g. Rho means density. Pressure head, velocity head is V1 square by 2g plus datum head is Z1. That should be equal to the total head section 2. P2 by rho g plus P2 square by 2g plus Z2, neglecting the head loss. The value of datum head Z1 and Z2 for the original pipe. Here is a original pipe. Z1 means the height of center of pipe from the datum line. If we consider here a datum line, and Z1 means the center of the height of center of the pipe. This one is center from the datum line. This one is datum line. Z1 means this. And Z2 is also the center of the throat from the datum line. Z1 is just Z2. So, here is, if pipe is horizontal, the level of the center line of inlet and that one is throat are equal. So, we can say that for a horizontal pipe, Z1 equal to Z2. So, this one is cancelled out. The remaining equation becomes P1 by rho g plus V1 square by 2g equal to P2 by rho g plus V2 square by 2g. So, now take the same variables at the same side. That is P1 by rho g. This one comes to left to P2 by rho g equal to the remaining terms V2 square by 2g minus this one go right side V1 square by 2g. What we already said that H is the difference of pressure head between section 1 and section 2. That is the difference of water level from head section 1 and section 2. That is this represents the difference of pressure head. Pressure head means P1 by rho g. So, P1 by rho g minus P2 by rho g means difference of pressure head. So, P1 by rho g minus P2 by rho g is what? Is H. H is difference of pressure head. So, this equation becomes S equal to V2 square by 2g minus V1 square by 2g. Let's say this one is equation first. Now, we should use the continuity equation. We already said that there are two equations we are going to use. One is Bernoulli's equation, another one is continuity equation. From continuity equation, the continuity equation says that the total discharge at section 1 should be equal to total discharge at section 2. So, this means discharge at section 1 equal to discharge at section 2. Discharge, the formula of discharge is area into velocity. That is A1 area velocity V1 equal to A2 area into V2 is discharge. Or the value of V1 will be A1 A2 V2 by A1. This value of V1 put into equation 1. Putting the value of V1 in equation first. Then equation first becomes S equal to V2 square by 2G minus V1 square. V1 means A2 B2 by A1. A2 B2 by A1. V1 square by 2G. So this becomes B2 square by 2G minus, here is A2 square B2 square by A1 square into, here is 2G. So let take the common, B2 square by 2G. Here remains 1 minus, here remains A2 square by A1 square. This one is taken common. Now, B2 square by 2G, let's take LCM A1 square. So, A1 square minus A2 square. Or, this one is the value of H. So, here value of B2 square will be B2 square equal to 2G H. This one go in numerator. A1 square by A1 square minus A2 square. Or value of B2 will be square root of the whole terms. 2GH A1 square by A1 square minus. So, root 2GH, the square of A1 and root cancel out, then A1 comes outside, then remains root A1 square minus A2 square. Now the discharge can be calculated as, now discharge. Discharge can be calculated from the section 2. The section discharge of section 2 and section 1 are equal. So we are going to calculate the discharge from section 2, that is area into velocity, A2 into V2. A2 into the value of B2 we already calculated is root 2GH A1 by root A1 square minus A2 square. Root 2GH A1 divided by A1 square minus A2 square. Then the ultimate equation becomes root 2GH A1 A2, this one is divided by root under A1 square minus A2 square. This one is the equation of Venturimeter to calculate the discharge in a pipe. This is the derived equation, that means this is the theoretical equation. If we calculate the actual discharge in the pipe, we should multiply this expression with the coefficient of discharge. CD be the coefficient of discharge. CD means the ratio of theoretical discharge and actual discharge. So, the value of actual discharge will be calculated as actual discharge CD times theoretical discharge. That is, CD times theoretical discharge is root 2GH A1 A2 by root under A1 square minus A2 square root. So, this is the actual expression for the Venturimeter to calculate the discharge in a pipe. Thank you for watching this video. Please like, share and subscribe my channel for similar videos.